Hi everyone. So in today's video, we are going to talk about something very important in AI system, which is guardrails. Okay. So now we all know that large language models like ChatGPTs are very powerful. Okay, but they are not always reliable. Why? Sometimes they can give wrong answers, generate unsafe contents, or even leak sensitive information. So the question is, how do we control AI in real-world applications? So that's exactly where guardrails comes in. Okay. So the simple definition of guardrails, as you can see in my screen, is guardrails are safety and validation layers placed before and after the AI model to make sure the system behaves correctly. So you can say the guardrails is equal to control, safety, and reliability of AI system. So let's understand this with a simple flow. So you might have used the chat GPT on your desktop or mobile application. So there are already guardrails in place. Okay. When you send any input, then input guardrails checks it, then the request goes to the AI model, then the output guardrails validate the response, and finally the response is sent back to the user. Okay. So basically you can think of it like a security system where input guardrails protect the system and the output guardrails protect the user. Okay. So let's talk about input guardrails. Okay. So basically this checks happen before the request reaches the AI model. For example, blocking harmful or abusive content and detecting prompt injection attacks or masking sensitive data like phone number or email or validating the input format. So basically we clean and secure the input before processing. So this is input guardrails. Okay. Then comes the LLM part. Okay. So next comes the AI model itself. This is where the prompt is processed, RAG retrieved data from vector database, and the response is generated. But remember, this is the most unpredictable part. Okay. Now we have the output guardrails. This is very important. Okay. After the model generates a response, we apply output guardrails. Basically, this ensures no unsafe or toxic content is returned. Okay. The answer is accurate and grounded, and the format is correct. For example, if you want a format in JSON format for APIs, so it will give the response accordingly. Okay. And also it ensures that business rules are followed. So if even if the model makes mistakes, guardrails can catch it. Okay. So let me give you a real world example. Suppose I am building a RAG based chatbot for internal company documents or legal data. So here how guardrails will work. So there will be a input guardrails which blocks the queries like give me confidential employee data. Then the AI model retrieves answer using vector database like Pinecone and tools like LangChain. Then output guardrails comes in picture. Okay. It ensures the response is only based on trusted documents and it prevents the hallucination. So I would like to explain the flow using an image. So I already have an image of this flow, as you can see in my screen on the right side. Okay, we can see the very nice picture, colorful pictures. So we can understand how guardrails work. So you can see that on the left side of the picture there is a user input. Okay, everything starts from here. The user, a user sends a question or request to the system. Okay, then comes the input validation part. Okay, so this is very important. So basically, before we send this input to AI, we don't trust it blindly. We first validate it using input guardrails, which you can see here. Okay. Then there may be cases, uh, basically, if the input is unsafe, for example, like there is abusive content or there is a prompt injection, and if your user is asking for sensitive data, we block it immediately. As you can see in the red, we have blocked the input. Okay. So basically system will protect itself here. Okay. Then we have the pass case, which is basically the green line. that you can see. If the input is valid, then only it moves forward for processing and sent to LLM. Okay. Now the request goes to the AI model. This is where LLM processes the prompt. It may use RAG, vector database, and generate a response. But this is the most unpredictable part. Then we have the output validations. Okay. So now even if after AI generates a response, we still don't trust it blindly. Okay. So in this case also there can be a fail case. Okay. What we will do if it fails, we will basically block the output. If the response is harmful or contains wrong information or violates the policy, we block the output. Okay. So here the system protect the user here. Okay. Got it? Now we come to the pass case, which you can see in the green line. Okay. If everything looks good, only then we send the response back to the user. Okay. So the real world example, you can say is say for example, let's say we build a chatbot for company data. If user asks give employee salaries, okay, then we have the input guardrail, which basically the block the user query at the input because this is a sensitive information. Okay, if AI generates wrong or sensitive in answer, then we block the output. Okay, if there is any sensitive information related to any other employees, for example, you are an employee in an organization and you want to know the salary of any other employee. So basically the salary is very confidential for an individual. So if we you ask the chatbot about the salary of any of your colleagues, so basically it will block. Okay, and it ensures that only safe and correct answers are returned. That's how real AI system work. Okay, so basically there are different types of guardrails. We have the rule based, okay, then we have the AI based moderation, then we have the schema validations, then we have the retrieval based grounding using RAG. One important thing to understand here is that guardrails do not make AI smarter. They make AI system safe, reliable, and product ready. Okay, so to end this lecture, so whenever you design an AI system, don't just think about the model, think about control, safety, and validation. Okay, hope you understand the guardrails, why it's necessary. Okay, that's it in this video. Thank you.